Greetings everyone. This is Ritvik and I am pursuing my computer science BTech degree from Amrita Vishwa Vidyapeetham, and today I am going to be discussing about the basic concept of graph and its basic implementation. So, let us first know what a graph is, why we need it, its various implementations and representations. So, a graph is a data structure that consists of the following two components. One is the finite set of vertices called nodes, and second is a finite set of ordered pairs of the form u, v called the edges. So let us first see this. The first one is called the nodes. They are finite sets. And the second are a finite set of ordered pairs of the form u, v. These are called as the edges. So basically a graph is nothing but a connection of nodes through edges. But this brings us to the next question. Why actually do we need a graph? I mean, what what is the real life application of graphs? See, graphs are used to represent many real life applications. Graphs are used to represent networks. One major use of graphs is networks. The networks may include paths in a city, maybe path in a city, just like a Google Maps, or a telephone network or a circuit network. Could be anything. It could be a path in a city, or it could be a circuit network, or a telephone network. Graphs are also used in social networks like Facebook and LinkedIn. For example, in Facebook, each person is represented with a vertex or a node. Each node is a structure that contains information like the person ID, the name, gender, etc. etc. So it is also important to understand that all the social networks like Facebook deeply use graphs. So in, let's say, in Facebook, we have every person as a node. Every person is a node. The node contains information about the person. So now we know what a graph is. Why do we need a graph in real life? And let us now know the basic representations of graph. There are two most important representations of the graph. The first one is the adjacency matrix. Adjacency matrix representation. And the second one is the adjacency list representation. So there are two more representations, which are the incidence matrix representation and the incidency list representation, which are not of concern right now for us. So let us first discuss what an adjacency matrix is. To define an adjacency matrix, it is nothing but a 2D array of size v cross v. So it's a 2D array of size v cross v, where v is equal to number of vertices of the graph. Let us look at the image that I'm going to show you right now and understand what adjacency matrix is. This is a directed graph with 4 nodes. So as you can see, a matrix has been created and whenever there is a connection between two nodes, that slot, that I comma j is actually represented with 1, and when there are no connections, 0 otherwise. So let us see. From 0 to 0 we have no connection, and hence a 0 is here. From 0 to 1 we have a connection, so there is a 1. 0 to 2 also we have a connection, so it is 1. But 0 to 3 there is no connection, and 0. Similarly, for all other nodes, this can be defined. So this is an adjacency matrix. But what are the advantages and disadvantages of using that adjacency matrix? Let us have a look. So the pros. Always the pros first. The most important advantage of using an adjacency matrix is it is very easy to implement and follow. So it is easy to implement and follow. Another important advantage of the adjacency matrix is removing an edge takes just big O of one time. Means removing an edge is very time efficient. Big O of n time. Sorry, 1. Let us also see the disadvantages of using an adjacency matrix. So the cons of using an adjacency matrix is it actually is a very space complex process. So it consumes a lot of space for, even inserting a single vertex takes big O of v square time. So it is very space complex and should be implemented only if the user has no constraints of space but has constraints of time. So different representations of graphs can be used according to the situation, the need of the user, and the ease of implementation. So this is one point to be understood. Now this representation of matrix is actually very space complex. It takes big O of v square time, where v is the number of vertices of the graph, and even adding a vertex also takes the same amount of time. Takes big O of v square. So now let us know what adjacency list is and when it can be used. So an adjacency list is actually an array of lists, okay? So it's an array of lists. Also, the size of this array is equal to number of vertices. So size of this array equal to number of vertices. Let us see an image that can help us understand the adjacency list in a more clear way. So in this undirected graph, we see 5 nodes. The adjacency list can be represented as whatever nodes are connected to the given node. So if we start from the node with label 0, we find that it is connected to 1, 2, 3 and 4. And if we consider the node with label 1, we see it is connected to node 0 and node 3. And similarly, for other nodes, this adjacency list representation can be defined. So this is how an adjacency list is. Now, the most important part, the implementation of a graph. So to implement graph, I have defined three Java files. One is graphnode.java, other is graph.java, and the third one is driver.java. So guys, we begin with defining a graph node and test its working. A graph node actually contains a label and its adjacency list. Here, one important thing to note is that we'll be using a Java utility module called the ArrayList for representing an adjacency list. So we'll just comment it out here. We'll be saying this has labels, this has a label and adjacency list. We are using an array list for representing the adjacency list. So let us begin implementing our graph. So this public class graph node, in which I'll be having integer label and an array list of the type graph node, which I'll be naming as adj list. Now I'm having a constructor which actually initializes this label and the graph node, takes the integer l where label is equal to l, and adj list new array list of the type graph node is created. In the driver.java, we can actually declare a graph node. We can declare many graph nodes. Let's say graph node n0 is equal to new graph node of 0. Similarly, graph node n1 is equal to new graph node of 1. This is just labeling and creating the graph node. Graph node n2 is equal to new graph node of 2. And let's create one more. Graph node n3 is equal to new graph node 3. Now we can add into the adjacency list n1. We can actually add the edge using this. If I have to link n0 and n1, then I do n0 dot adjacency list dot add of n1. This actually creates a link between n0 and n1. Similarly, we can do for others also. Let's say if I want to create a link between n0 and n3, so I could do it like this. So this was actually basic defining a graph node and testing it with our driver code. We'll be defining another important graph class which contains an array of nodes. This will be graph.java, and we define this class, and this class has an important role. It contains an array of nodes, it creates and initializes the nodes, it also includes an add edge method that is used to add the edges. So we'll just state our goals here and implement them subsequently. So our graph class will contain array of nodes. It will also create and initialize them. the add edge method, which will be used to add edges, and the driver program will use this method to populate the adjacency lists of the nodes. So back to the graph.java. We have, okay, so let us achieve our goals one by one. First we need to create an array of nodes. So let's create an array of graph nodes. I name it as node, and I also have to have an integer size. So if now I'll initialize this with a constructor, int n, where size will be equal to n, and node will actually be equal to new graph node of size. Node is actually an array of nodes. Now let's populate the array. For int I is equal to 0, I less than size I plus plus, node of I, let's initialize the node of I is equal to new graph node of I. This actually is initializing each array node with a graph node. So the initialization and creation of the graph of the nodes is done simultaneously. Now the next motive is add the add edge method. So let us add it. Public void add edge of, we'll be adding an edge from a specific vertex to a specific vertex. So we'll be having integer from and integer to. In this we'll be actually making the vertex with the index from as the adjacent element of the node with vertex 2. It's just basically linking the from and to nodes, and that is what an edge is, right? So in the graph driver.java we'll be having graph g, will be initializing the graph here, new graph of let's say 5 something. So g dot add edge, we add an edge from 0 to 1. Similarly g dot add edge, let's say from 0 to 2 again, and g dot add edge from let's say 1 to 4, and so on and so forth. G dot add edge from let's say 2 to 1, and g dot add edge let's say from 2 to 4 too. So let's just leave it for now. So that is how you add an edge. Now let us move on. Let us understand and see how we can print the adjacency list of each node of the graph. So let's check if the adjacency list was rightly created by adding a print method to print the adjacency list of each node. You have to note that call to print method of graph delegates the printing of the adjacency list to the respective nodes. This is a very important thing. So we have to understand that a call to the print method of graph actually delegates responsibilities, delegates the printing to the respective nodes. So we'll just do g dot printf and define the print function in the graph node.java as well as graph.java. Since since when we are printing method of graph, it actually delegates the printing to respective nodes. So we continue to add the print method in graph.java. Public void print for int I is equal to 0, I less than adjacency list dot size of, because it is an array of nodes, I plus plus. We do system dot adj list dot get of I dot label. This will actually give us the label of the adjacency list. And now we also add so now that we have added the print function in the graph node.java, which will actually give us the label name, and now we have to add the same method in graph.java so that delegation of the printing happens between graph.java and graph node.java. So now we add the print method in graph.java, for which I do public void print, and for int I is equal to 0, I less than size, I plus plus, system dot out dot print I plus, this will print the label for us, we print the node label, and now we do node of I dot print of. This will actually delegate the responsibility of printing, delegates the responsibility of printing to the nodes. This is a very important thing to note in object-oriented programming. Now we just print another line. Just prints new line. Now we have successfully completed the basic implementation of graph by adding a print method and successfully having checked that edges are added and the adjacency list is printed correctly. So that's it for now, guys. Thank you so much for watching. Hope you liked it.